Hello everyone, my name is Varun Modi. Here I am representing my final project report on an agent-based approach for modeling dynamic of contagious disease spread. From the publisher model, they have developed using the SIR methodology for communicable disease in urban area. To stimulate this model, publisher has used the following parameters like latency period, infection rate, recovery time, and average time to recover. This slide represented as the SIR model for the contagious disease spread. As we can see, there are the different stages like person got exposed, the stage number 1, stage number 2, and the recovered runtime. Now I have taken the original publisher model, which was based on the geographical information system, and it was converted into the NetLogo model. As we can see, this original model in the NetLogo, which has recovery rate, infection rate, initial population count. Now I have added several additional parameters to enhance this model. As you can see in this slide, I have added mortality rate, healthcare capacity, quarantine effort. Also I have added plot for the fatality. In other plot, I have added non-infected count as well as healthcare capacity. As we can see in this simulation, mortality rate is 0 and infection rate is high. So infection is spreading quickly through the population. To validate this model, we are going to assume there is no infected person in the closed simulation area. If that is the case, we expected there should be a spread within the population. As we can see in simulation run, plotted graph has all the parameters and the flat line which indicate there is no spread within the area. Now as we can see, it's showing the USA COVID-19 run in relative manner. To run the simulation, I have reduced USA total population to 1000. So as the reported cases in the relative term, in this simulation infection rate is showing 80%, recovery rate is 86%, fatality rate is 12%, and healthcare capacity is 15% of total population. This data was derived from Worldometer, and as we can see the graph for the contagious disease spread. Now for the methodology, we called it as a quarantine or stay in shelter for flattening the contagious disease spread. In the simulation run, we are applying the quarantine methodology on the 17th day of simulation run. So as we can see here in the graph, after applying the methodology, it reduces the number of infected count. Now this slide shows the active cases reported in the New York. New York implemented the partial stay in shelter methodology on May 28th. As we can see in May, the number of cases decline or it stay as it is. This slide represented the validation for infected population within the closed area. Now this slide is all about the data validation with the real world data. So as we can see, the first column represented as a number of days, second one represent as a original model infected number, and the third one represent as a real world infection count. As we can see, by enhancing the model, we were able to achieve the result closer to the real world data. Thank you.